Hello, this video is going to help with section 14.5, and it is different theorems and conditions using rhombus, rectangles, and squares. So let's look at the different theorems from the textbook. So this is straight from your textbook. This is theorem 53, and you can see that this first one says that ABCD is a parallelogram. That's why would they have the opposite sides parallel, and that AC is perpendicular to BD. So that means they meet at a 90-degree angle. So if we have this information, we can prove it's a rhombus. Okay. The next theorem, 54, says, okay, if you have A, B, C, D, and it's a parallelogram, which again we know because opposite sides are parallel, and 1 and 2 and 3 and 4 are congruent, then it's a rhombus. Okay, so and that one, well, this one didn't show the proof of that in your textbook, but that one's kind of a cool proof. Anyway, 55, the last theorem here says, all right, if it is a parallelogram and AC is perpendicular, congruent to BD. So if those diagonals are congruent, then it's a rectangle. So we know if the diagonals meet at 90 degrees, rhombus. If they're congruent, rectangle. And those, I think, yep, that was the only three theorems we had. So let's go through some example problems. So let's look at this picture here. All right, so we know this is a parallelogram because we have the little symbols, right? Here and here. Now, what shape better defines this than just parallelogram? Well, we have one diagonal and all four of these are congruent. So which theorem did we look at just now that says if you have this, and what shape did it say? It said if you have 1, 2, and 3, 4 congruent, well, these ones all four are congruent, but it says if these two are congruent, these two are congruent, then it's a rhombus. All right, what is my next shape? So you know it's a parallelogram, and I know that on the diagonals, this one's congruent to this one's congruent to this one. Did we have any theorems that told us what this shape would be? So we had one about diagonals being 90. We had one about the diagonal angles being congruent. Those both led to rhombus. The rectangle one says the diagonals have to be congruent. That's not what this says. This one says they bisect. So this one is not enough information for us to decide if that's a rectangle. Okay? All right. What about, let's look at through some different problems. You might see something like this. How would you know what y is? What do we know about this one versus this one? Well, we know because it's a parallelogram that this side is congruent to this side and this side's congruent to this side. We also have to know that this whole thing is going to equal this whole thing. So basically, these two have to be congruent to each other. And so we'd set them up equal to each other and solve to find y. And so I was just walking through how would you use the logic. Well, you might want to keep those parallelogram theorems convenient out as well. So let's look at a couple problems and make sure that we understand how to solve them. So let's say we're looking at this problem right here. We are told it is a parallelogram. And so what would we need to do what would X be to prove that this one is a rhombus? So you might be told, okay, it's parallelogram. What would X need to be to show it's a rhombus? Well, what would we know about these angles? They'd have to equal each other. So you set those two equal to each other and find X. Okay. Another example that you might see is like 15 here. For what value of X is the given figure? Okay, so what value would make this one a rectangle. So how would you solve that one if you wanted it to be a rectangle? Well, for this one in particular, they would have to add up to 90 degrees. So you would say that one plus that one has to equal 90 degrees and solve that equation from there. Okay, what about this one, rhombus? What do we know about an angle from here to here? Well, what we do know is this one has to be 90 degrees that they did not give us. So this one plus 90 has to equal 180 degrees. And then you solve the equation from there. Okay, number 17. If this is a rectangle, what could we say about this angle versus this angle? So I was trying to think of, this is a transversal. Nope, that one, my thought process wasn't right on that. I was thinking, well, anyway, they add up to 180, but I don't have this one. I know they are equal to each other. I was trying to think of why. There was a theorem with parallelograms that said, well, then these are 90 degrees. All right, well, I'm going to say between the theorems of a parallelogram and a rectangle, I don't remember the exact theorem now for some reason, that this one and this one would have to be congruent to each other because this one is a 90, this one's a 90, and this bisects it. So there's a theorem that says that diagonal bisects that angle, and so we can assume those are going to be congruent and set them equal to each other. Okay, so I just showed you, I didn't work them out, but I showed you the logic behind looking at some of the rhombuses and the rectangles and solving for x. So anyway, and then there's more help with the virtual nerd video, but I thought I'd help a little bit with this.